Hello, and welcome to this first episode of Bits of Wisdom. Today, we are talking about what this is. And when I'm saying this, I'm actually referring to the keyword in JavaScript that we are going to talk about. This is our first episode in a series of little bits of information about JavaScript that is going to be called Bits of Wisdom. We're going to talk about several more advanced or possibly less advanced concepts, but which usually come up in interviews. And usually it's tricky questions which, especially if you come from another programming language, you're going to have problems answering because it's stuff that JavaScript does a little bit differently. Today our topic is the keyword this. You know that the this keyword in other languages usually refers to an instance, to the current object that you have created using the new keyword starting from a class, possibly. In JavaScript, this is a bit tricky. Let's start by talking a little bit about objects. We are going to create an object using the object literal syntax, and we are going to store it in a constant. We're going to call it, let's not call it object, let's call it something like person. Our person object, as I said, is going to be an object literal, and it's going to have a few properties, like, let's say, name, which is going to be my name, Paul. And maybe we're going to have an age, which is going to be 35. And we're going to have a weight, which is going to be 90, and we're talking kilograms. And maybe we are going to have a height, which is going to be 1.85. We actually want this person to also have a method, and methods are only functions which are defined inside objects. So we are going to have a method here that's called calculate BMI. This method is going to return our BMI. The BMI is calculated as our weight divided by our height in meters squared. And if you don't know how to square stuff in JavaScript, you just put 2 stars and a 2. The double star operator is actually the something to the power of, and you have to specify the power that you want to use. In our case, it's 2. So it's weight divided by height to the power of 2, and we can use this object like so, and the method on this object like so, calculate BMI, and just call it. Of course, we're not going to see anything unless we actually console.log this out, and now we save. And of course, we have a referencer. Our weight is not defined. When we use an object like this and we want to access properties from the object, we can usually do something like console.log and say person.name or person.weight or person.age, and we are going to get that output in the console, no problem. Of course, when inside the actual object and we are inside the function that's inside the object, we could theoretically use person dot and person dot. But this is not the actual best way of doing this. And now that I have done this function, I notice that it has a few too many decimal places. We should restrict that possibly, and this is done by simply wrapping all of this into parentheses to make it an expression, and calling, because this expression is going to be replaced with a number, we're just going to call a method from the number constructor here that's called toFixed, and we can pass it a number of decimal places we want to round the number off to. Cool. Okay, perfect. So we could, in theory, use the object's name here, the constant we have defined, but this is not the preferred way of doing this, because if we at some point want to change the name of the constant, or this is during a refactoring, or maybe we use another way of creating these objects, referring to the name is very difficult to impossible to maintain. So we want a better way to refer to the object itself from inside of it. And this way is the keyword this. So we could use the keyword this, and we would refer to the weight or the height inside this object. Let's see if we save. We still have the same result. It's 26.30 and it's perfect. So it works exactly as expected. So until now, maybe you, if you have experience, prior experience with different languages, this might seem familiar, and it works in a very similar fashion to any other language. You can actually access the current instance, which is person, and use properties from it, but it's not that easy. In JavaScript, you could assign a different label if you want to the same function. We could have this function stored in a variable for later use, or maybe we send this function to another function as a callback, and that function will call this function, and it will use one of its own parameters to do this. So let's just store this function in a different variable at the moment, just to demonstrate what the problem is. So we'll say my calculate function is going to be person dot calculate BMI, and we're just going to send, or we're just going to store the reference of this function inside this other variable. So we're basically going to have another label for the same thing in memory. It's actually the same function in memory, so there should be no difference. And we could use this label when calling the function. We don't have to use the original object and the original function anymore. We could use this label to invoke our function. Let's do that inside this console log. We're going to use the myCalculate function here, and when I save, let's look in the console, we get not a number. This is quite interesting. Why do we get not a number? It was working previously, it was working perfectly previously when I used this label. Why doesn't this label work anymore? The answer is simple, because the keyword this is not the object anymore in this context. Let's just log this out inside here. We're gonna log out console.log this to see what this is, because that's the question of the day. We're gonna save, and suddenly, hey, this is the window object. That shouldn't be the case. Why does it do this? Okay, let's go back and call this label again. Oh, look, it's our actual object. That is quite weird. Why does it do this? Well, what you should know is that the value of this is established when we invoke the function. It's not set in stone when defining the function, so in this place, but it is determined at the moment of invocation, which is this moment right here. And the easiest way to determine yourself what this is inside the function, what the keyword this is inside the function, is to look to the left of the dot, of the period. If you see an object here, it should be pretty obvious. This inside the object is going to be whatever is to the left of the dot, whatever is left to the left of the period sign. In this case, it's person. But when we use a different label, like for example, my calculate function, here, we don't have anything to the left of the dot. We don't even have the period sign anymore. We don't have that. And we get the window object here. Okay, the more astute of you might say, okay, this is a global function. It's in the global scope. In the browser, our global scope is represented by a window. So probably if we would call this function on the window object, we would do something like window.myCalculateFn, and that's why we get window here. But it's not that simple, especially since constants and let variables are not actually stored on the window object. It's even more weird right now. But this is how JavaScript behaves. This is its default behavior. It's not the most correct one. And that's why we would like to fix this. And we can quite easily fix this. If we go to the top of our file and we just type a string here, that's called use strict. Okay. What this will do, it will change the way JavaScript parses this file. It will suddenly parse the file in strict mode, which it didn't until now. Strict mode imposes more strict rules with regards to how JavaScript interprets the file, and also JavaScript will helpfully throw more errors for us if we do something that's not going to be supported soon or that we shouldn't do. So let's save the file, and suddenly we see that this now inside the functional line 13 is undefined. This is better because it's more natural. We don't see anything to the left of the period sign. We don't have a dot or a period in our code. So if there's nothing there, we know that JavaScript simply uses undefined as a value. So this is undefined right now. This causes an error to happen in our calculate BMI function, but that's not a problem, to be perfectly honest. I'd rather have an error than have not a number, which is, by the way, a valid number. We don't want that in our code. It might cause further errors down the line. Let's just say that this error is better. Okay, so right now we get an error, which is perfect, and if we use the original label to invoke our function, we're going to see that we still get the correct result, and this is the actual object because we have it to the left of the period sign. So the first rule when thinking about this as a keyword is that this will be whatever is to the left of the period when invoking a method. Okay, and if we are in strict mode, which is the preferred mode, if you ask me, you will get undefined if there is nothing to the left of the period, which is perfect. We actually want that error instead of gracefully failing and causing several errors down the line. It's better if we get something explicit in the console. This is our first step. This is our implicit binding. So we saw that this actually receives a value at the moment of invocation. But we can also explicitly bind this if we would want to do that. To explicitly bind this, we could refactor our example here by just using the keyword bind, which is a method itself. And bind actually wants to bind a this argument to this function and return a new function which has a set in stone version of the this keyword. The this keyword will be whatever we set right here. So we could set the original object like person, for example, and this should work perfectly. If we now use this label, we won't get that error anymore, but our function is going to work perfectly. So we bound person here. We could bind anything, and since our function only uses weight and height, we could, for example, create a new object in here to have a weight of, I don't know, let's say 50 in kilograms and a height of 1.75. Let's say this is a girl, and save. And we have a BMI of 16.33. So we bound an object to this function as the this keyword, and we see it here in the console right here. And our function is using those values to calculate the BMI. As you've seen, we can bind our original object, we can bind anything we want to this using the bind keyword. We could not use this. We could get back to our original definition, which triggers an error again, triggers a type error. We could, at the moment of invocation, do a binding instead of at this moment when we created this constant here, or we could at the moment of invocation bind our this value. For example, this is where we invoke our function, but we're not going to invoke it by putting parentheses right after the name, but instead we are going to use another method, which is called apply. Let's use apply first. Apply is a method that actually calls the function, my calculate function, and as the first parameter to apply, we again can set this keyword if we want to. So we could use person here, and again we're gonna have our correct calculation. Apply also allows us to pass arguments to the function if we would like this. You could pass any kind of arguments to this function, like for example numbers, for whatever reason. These arguments would be passed into the parameters of the function. Our function doesn't have parameters at this time, so we could catch all those numbers in 1, 2, and 3. Sorry, 3. And this would work perfectly. So apply actually passes this array, but it passes each item in the array as one of the arguments of this function. So you could apply a new this and some arguments to the function when calling it. There's also another way of doing the same thing. We could use a different method here that's called call. Call is very similar to apply. It will call this function, apply this as the this inside the function, and instead of passing the arguments as an array, we would pass them simply as values separated by commas, I guess, like we would normally pass arguments to a function. So you could do the same thing this way and we would still get the correct results here. So we saw that there are 3 ways we could explicitly bind this to our function. The first and the most intuitive one maybe is bind. Bind is used on the function reference to bind this to it, and bind would return actually a new function. It's not the same one in memory anymore. A new function which has a bound value for this. That's fine, and we can use that function with the same constant or unchangeable value for this. We could also change the value for this when invoking the function, but we have to invoke it using either call or apply, and this would also set the value for this, and we could also pass it some arguments. By the way, bind can also pass arguments if you would like to. It could set some default arguments, I guess, or some it's a bit different from the default arguments, but it would set some of the arguments from the get-go for that function. Most people use bind only to change this inside the function. We used a normal function expression here inside of this object. What you could have done, because it's very trendy at the moment, we could have used an arrow function here instead of this normal function expression. And since we have more than one single line of code inside our arrow function, we're gonna leave the brackets here to establish that we have multiple lines of code, and we're gonna explicitly return something from the arrow functions. We reverted our original code so that my calculate function is equal to person.calculate BMI. So we have the same function reference stored inside both labels, inside this label and inside this label. We have the exact same function in memory. Now, if we call either of these, sorry, this is actually the function's reference, okay. What we see happening is that even though we still use strict, we have reverted to seeing window as being the this argument or the this value inside the function. Okay, and I guess we could use either of these labels. We could use my calculate function or the original label, and we would see the exact same result, even though we use strict. This is because something special that arrow functions do. Besides being a very concise way of declaring a function or of creating a function expression, they also do something to the this keyword. Namely, they use the value for this that they find in the current context, in the current scope. The scope here, where this function is being created, the scope here is window. Why is the scope here window? It's because we are currently in the global scope. In JavaScript, the things that actually have their own scope are either modules, the global scope, which is window, and which is the current case, or functions. We don't have a function that wraps this object so that we have a more narrow scope. We are in the global scope when declaring our person object. In the global scope, this is actually the window object, and we can easily prove this by typing out this in the console, and we would see window again. So we do have a this keyword inside JavaScript by default. We don't have to be inside of an object or inside of a function to access this as a keyword. We have it available at all times, I guess, and in the case of our global scope, this is represented by window. Of course, if you would be in Node.js, this would not hold true. You don't have the window object there, you have a global object. But as a side note, you also have a global this that is always the global object available to you anywhere inside JavaScript, and you can reference the global object using global this if you need to. So what the arrow function does is take the this keyword from the current scope and use that inside the function. So it's bound like we did it previously with the bind keyword. This is bound, but it's bound to whatever this is in the scope. It's like we have typed out here bind this, like as if we'd have done this. If we'd have done this, we would have the same result we currently had with our arrow function. This is called lexical binding. That's what that means. Lexical binding is binding this at the moment of declaration, or when we create the function, not when we invoke it. We've seen that there's an implicit binding, which happens by default if we use a normal function expression inside an object. In that case, whatever object is used to invoke that method will be this inside the function. We have explicit binding when we use bind or call or apply, where we can set our own value for this. And we also have this third case where this is bound lexically. It happens when we use an arrow function. The arrow function simply binds the value for this that it finds in the current scope. And in this case, the current scope is window, so what we see in the console is the window object. We can also easily show that if we have a function here, normal function, let's just call it a wrapper. If we have this wrapper function, the wrapper function doesn't have any kind of this keyword inside of it. It doesn't have any this inside its scope, the scope it creates. So now, right now, if we remember our rule, the arrow function, when it tries to bind to the current scope, to the this in the current scope, since this in the current scope is not defined, we will probably get undefined in our console, which is true, we get undefined. Oh, sorry, no, we get an error. If we wrap this object inside the wrapper, we should probably also move this up, and we should move this inside the wrapper function, and let's call the wrapper. We could have used an immediately invoked function expression, but this is also fine. And we see that this inside the function, because this inside this wrapper function is undefined, this inside the arrow function would also be undefined. If we change this wrapper function to be a constructor function, let's name it like the convention with a capital letter. This will be a constructor function. We could, of course, have an explicit this inside here. We could say what this is, but we will have to use the wrapper function a bit differently later on. So let's say that instead of having a person, let's move this out. Let's not have the wrapper function. Let's call this person now. It's a person constructor, and our person constructor will have a name as before. It will be the same thing. It will have an age of 35. Sorry, we should use the equal sign here. It will have a weight of 90, and it will, of course I used it wrong again, and never forget the this dot, and this dot height. which is 1.85. Perfect. We can now drop this object from here, and we might have a calculate BMI function. It can be an instance method or it can be a prototype method. Let's create it as an instance method. It should be the same for prototype methods. We're going to test that out. Let's say that this dot calculate BMI is equal to a function. Let's just return to our normal function expressions. Let's not use the arrow function syntax for now, at least. Of course, we have to extract this outside, and we have to, our refactored object is now a constructor function, so we would have to call new on the constructor function for the keyword this to work. Note that normally inside functions, so you could not invoke the function like this, like person. You could not do this. If you do this, you're going to get an error. You cannot set the property name of undefined because this inside the normal function is undefined. But if we were to actually initialize a new object starting from this person, like for example, let's say my person is a new person, this would work perfectly. It would set this to be the instance, the current instance, and we would have the name, the age, the weight, the height, everything set on the current instance. Also, we would have the instance method called calculate BMI at our disposal, and we could use my person.calculate BMI. And we would see the correct answer again. And this is our person object. Our person object created with the person constructor right here. We see that it works this way as well, and we can use the this keyword inside the constructor function to set whatever is this, if you would like, whatever is on the current instance. But again, the same holds true as with object literals, because this inside the calculate BMI function is whatever is to the left of the period. In our case, the my person instance, which was created with new, which automatically will have this. If we were to say refactor this to be an arrow function again, so we're gonna have our arrow function back. This time we see that the problem that we had previously does not occur anymore. This is because in this case we are inside this person constructor, and our arrow function will use this from the current scope, which is perfect. It actually keeps working. Let's move this function, instead of having it inside here, let's comment this out. I'm gonna copy this part, and we are going to use the prototype of the person.prototype. I mistyped that. Prototype dot calculate BMI is going to be, let's start out with our normal function again. So we're going to delete the arrow and have a normal function here. And we're going to uncomment all of this. And let's just say for prettier to kick in. And we see that the calculate BMI function works perfectly on the prototype as well. But now when we refactor to an arrow function, we are back to the window issue that we had previously. Again, because at the moment of the function creation, when we create the arrow function, we are in the global scope. We are in our files scope, where window is whatever this as a keyword is in this place. Again, lexical, this binding. So we saw that arrow functions actually do work inside constructor functions. They work the same as normal function expressions, which is very nice. But outside, when we use the prototype to declare our function, we return to our initial problem where window is the currently bound this value. But if we use a normal function expression when declaring the prototype, we have our expected this value, so our person instance. But again, the same issues which we had previously occur if we use the normal function expression and I have the new person instance. But if I declare a new label for the same function, like for example my person person thought, calculate BMI. And again, I'm going to use the function reference here. If I use the new label to invoke the function, so let's see, my person calculate BMI. If we save, we see the proper result. But if I use the new label, again, we have an undefined this value because we use strict. If we weren't using strict, we would have window again here. The issues hold true even if we use constructor functions, so it's nothing new in this case. And as you probably know, or we will explain in another Bits of Wisdom episode, constructor functions are actually the original way of creating what we now can with classes in JavaScript. So it's essentially a class, if you want to loosely name it that way. The same would happen if we would use classes instead of a constructor function. To recap, we have three different situations. We have the first situation where this as a keyword is whatever is to the left of the period sign when invoking the function. Of course, if we don't have anything to the left of the label, we have two different situations. If we are not using useStrict, it's going to be window. But if we use strict mode, it's going to be undefined. This is going to be undefined in that case. So these are the straightforward implicit bound this values. We could explicitly bind this using call, apply, or bind, in which case we as programmers establish what this means inside our methods. But we also have another situation, the situation where this is lexically bound to our function, in the case where we use arrow functions to define our functions, our methods. In that case, this will be whatever the value of this was inside the current scope. And you just need to determine what kind of scope you are in, whether you're in global scope, module scope, a function scope, or maybe a block scope. It doesn't matter, whatever this was inside that scope is going to be whatever this is inside the function. That's about it. And I hope to see you next time in our next episode when we discuss another bit of wisdom. We'll see what that one is when we come to it. Bye!